All right, this is the answer key to week 6 worksheet. So for this one, we got 2 ortho-para directors on our ring, and you got to put them on one at a time, and they're meta to each other. So the first thing we got to do is we have to do Friedel-Crafts acylation. And the reason why we need to do this is, one, if you want a straight chain like this, you have to do acylation. You can't do it with alkylation because you'll get a carbocation rearrangement. So we're going to get that acylation. Now we have a meta director, right? This is a meta director. It's going to direct the 2 meta positions. And we can do our Fe, Br3, Br2. I know it's normally Br2 and Fe, Br3. It doesn't really matter which way you write it, as long as you have the right reagents. And we'll have this. And then the final step is just going to be doing the reduction H2 and PDC, right? And I'll get to your product. Okay, next question here. We again have 2 ortho-para directors, so we need to put them on one at a time. Generally, you do your Friedel-Crafts reactions before you do any other reactions. And there are good reasons for it, but we didn't discuss them in lecture, so I don't think you're required to know that. And if you did these out of order, it's probably not the end of the world, and I would probably get you full points to do it because Dr. Davis did not say this. So I'm going to put on my meta director, and then I'm going to put on my nitro group on the meta position the way it is. And then I can actually do this reduction in one step because this H2 PDC will reduce the ketone to an alkane if it's a benzylic ketone, but only if it's a benzylic ketone, not other ketones or aldehydes, just benzylic. And then the NO2 group will reduce to an NH2. So that's going to be for that problem. All right, for the next one here, again, we have an R group, which is an ortho-para director, and this one is a meta director. This is probably like the easiest problem on the set. So this is going to be Friedel-Crafts alkylation. Let's put in the alkyl group because it's an ortho-para director. And then we can do our sulfonation. Right, and we'll get that. Okay, this last one, we got 2 meta directors and ortho-para director. Everything's meta to each other, so this Br2 needs to be the last thing we stick on here. So if you want to do retrosynthesis, which we haven't really done, which is like working backwards, you would see this and say, I have to come from this intermediate. Or not intermediate, but from this structure, right? And somehow I have to go from this structure to this structure. And the way, of course, we do that is we always do our Friedel-Crafts reactions first. Right? And then we can do HNO3 SO4. Right? And then we get there. Okay, and this one. This is probably going to be a super short video because there aren't a lot of problems here when we did exam stuff. Okay, now this is just like a stack of reactions to predict the product. This first step, of course, is going to be nitration. It's going to get you this. Second step is going to reduce it, and H2. And then the third step, I would actually draw both the ortho and the para products. Usually para is a little bit in excess because of sterics. But normally for ortho-para directors, you draw both. For meta directors, you only draw the meta. Okay, this is for step 1. You are going to draw this. So you're going to get this carbocation, and then you're going to get a hydride shift to make this carbocation. So you should put on an isopropyl group. Step 2. So go ortho or para, but the para is the major product, so we're just going to draw the para for this. And then step 3, this is the Wolff-Kishner. Reduction. It works on all ketones and aldehydes and reduces them into alkanes. So this will do that, make that product. Okay, and this last one's the one we did in lecture where mechanistically, these are not like reaction steps, so I'm not drawing 1, 2, right? You deprotonate this, and then you have this, and we're getting this to attack here, right? And a few steps with regaining aromaticity and whatnot. And I forgot to have a follow-up. Oops, I probably should have by resonance, you can have the negative charge of this oxygen or that oxygen. I just drew the double bond there, so I'm drawing it this way. I should have had an acid workup set to protonate it, but I didn't have it, so this is like what you draw for your final answer. This is still in base. But good, that's the end of this video. Hopefully, you did well in the exam and you study hard for the second one.